Okay, here we go again. Several custom handrails. We're going to get into the second part of this video on the volute, and this is the one that gets a little bit more in depth with the wreath fittings. So I'm glad you're on board here, and we're going to get started pretty quickly on this next video. So little explanation for the last one. My audio was not in sync with the video. I had to take it down and repost it, so if you commented or looked at the other one, sorry, I had to wipe it out and start over. So here we go with a new video, part 2 of the volute. So let's get started. So this is the procedure that you would use to get started on this drawing, to be able to get our two wreath fittings coming down into this volute cap. So the first thing you want to do, because we're doing this by the old tangent handrailing, you wonder why it's called that? Well, because it's based on tangents. So we're going to deal with the center line of rail here, and we're going to put some tangents in at these joints. We'll put a straight line tangent to each one of these joints here, and this is how it would basically be set up. This would be your known pitch coming down from our straight rail, would be this first tangent. And then it's going to intersect with this mid tangent and come around all the way down to our, what we're going to call the level tangent, because it's going to level it and joining into the cap. So let's now start with getting some labels on here so that we know what we're doing when we go into the elevated view here. And now what we want to do next is we're going to have to unfold all these tangents out into a straight line here, so that we can project them up onto our elevation drawing. So let's do that. We're going to swing each one of these tangents. This one we're going to swing around to this point, and then we're going to swing this whole thing up to this point. You can almost picture a column of soldiers when they do that pivot around on a corner. And we're going to line them all up straight here, and all at the proper length. So from there we're going to go straight up into our elevation drawing, and we're going to want to put tangents up here and find the pitch of each one of these tangents, how they would be in actual elevation. So we're going to extend our known pitch coming off our straight rail down to this first intersection at point D, and we're going to put the level tangent in at the height that we're shooting for our finished volute height. And we're going to join those two intersections with a straight line. You always want to go through the midpoint from one wreath fitting to the next one with a straight tangent line, so that when you butt those things up, you know that they're going to fit together. The next thing we want to do is take our drawing here, this portion of it, and we're going to move it over here so that we can separate it from all the noise here and get that thing started into a face mold drawing. So before we do, I'd like to show you a little bit better what exactly we're doing here. The tangent handrail system, it's amazing that they're able on a flat piece of paper to almost bring to life a 3D object by rotating the planes. They didn't have 3D drawing programs then, so they accomplished all that they're doing by rotating planes. And I'll show you what I mean here. We're going to rotate this tangent stretch out or unfold up over our plan view and show you what that looks like. Let's rotate that on this fold line right here up into elevation. We have our known pitch coming down here with a straight rail, and it intersects at this point here, point D, and wraps all the way down to point B, and then you have your level tangent at the bottom. Now this is exactly what is going on in the process with this tangent handrailing from the old books. We're rotating and unfolding different planes, and we're going to put a surface on here which is going to be called the oblique plane, and this is what we're shooting for down here in this area here. We're going to put an oblique plane in there and transpose all the information from our flat plan view into the oblique plane, which is actually in elevation even though it's on a flat piece of paper. And that's how they accomplished all this. So let's project now our plan view up onto these surfaces, which is what we will be doing when we go about this the old world method. But if they had the 3D drawing programs back then like we have, I guarantee you they would be doing something like this. So there you go. That's what we're trying to accomplish here. So let's just show you how this mechanically works again. If we were able to fold this oblique plane here up, straight up and down, and then take that whole thing and rotate it back down to the ground here. This is what we're attempting to accomplish. This is actually a finished face mold right here. And we didn't have to go through all this nonsense that you have to do back in the day to be able to get it. So I just wanted to show you that to give you a better idea of what this is all about and what we're doing. And the reason that they did it this way is because they didn't have the technology that we have today. So let's set this drawing up, and the first thing that we want to do is we want to be able to, I'm going to go into the top view now. We want to continue this known pitch, this straight rail pitch, all the way down to the baseline. And if you look that into the books, they call that the vertical trace there. That's going to be part of the foundation of our oblique plane. And you saw on our other drawing how that the surface, the oblique plane surface, was laid directly on, go back here a minute, it was laid exactly on this vertical trace, and also on what we're going to put in now, the horizontal trace. That oblique plane sits perfectly flat on those two lines there. So let's go back to top view and go to the next step here. Let's see. Now we're going to take a line from this intersection here of this vertical trace where it hits the baseline, and we're going to draw a line from there down through the joint. Okay, this is going to be the directing ordinate that's going to direct many of the lines in this drawing and process here. So this is an important line going on right now that we've just established. So after we get that directing ordinate line, we're going to extend it out, and it can be any random amount, clear of our plan view drawing, so to avoid some confusion. Extend it down and draw another line perpendicular to that, stretch it out. Okay, then we're going to copy this directing ordinate line through the other joint and extend it down to hit this baseline, we'll call it. And then we're going to extend all these lines. We're going to put one through the intersection of the tangents as well, because right now we're going to be trying to establish the tangents on the oblique plane. So we're going to do some things to reference those. So we have 3 lines here, one through each joint and one where the intersection of the tangents lie. I'm going to extend these lines up, and then we're going to put another perpendicular line across. It doesn't matter what distance this is, just get it clear of your drawing so you don't get confused with a bunch of conflicting lines. So we're going to put that at perpendicular to these 2 directing ordinate lines. And then we're going to come up this distance. We'll call this the rise of the section. From point A to point E again. We got 5.4 here. So we're going to go up that same 5.4, and we're going to connect where that height of that line down to our baseline. And we're going to put this line in here. And from that line, we're going to take perpendicular lines from this line here. This is perpendicular coming off at this point. We're going to put that in, and that length of that line will represent the length of this line from point E down to the baseline. So that length is the same. We're going to do the same with this line. This from this baseline to where the intersection of the tangents, we'll put that in, and then from our baseline up to the joint, we'll put that in. Now we can put the tangents in here. There we go, we got them labeled. So this is the tangents on the oblique plane. So we're getting there. So now we're going to put in a whole bunch of other lines and basically do the same kind of thing. We're going to determine the length of these lines from the baseline to the inside and outside radius of our plan view handrail. So I just threw a whole bunch of lines in here, and we also have them up here. They're perpendicular to this line. And we're going to determine the distances on each one of these lines to our plan view handrail layout on the inside and outside radius points. So we're going to determine the length from here to here and from here to here, and we're going to take them up here. A lot of times I'll just use a circle. I'll show you what I do with this here. Circle, another circle, and then I'm going to move them. Up here to this point, and then I'm going to take and put a little tick mark there and get these out of here then. Alright, and once I have to do that with each one of these lines. And I like to put some close to this, the sharper curve here, just to get it defined better up in our oblique plane. You don't have to do it, I just am OCD about it. So we're going to throw the face mold lines in here now. And the joint is always perpendicular to the tangents. So we could have put those lines in there before we even put the face mold lines in. Throw a line in where our joint is perpendicular to the tangent, and there's going to be our joint lines, and then we're going to connect all these lines to get the inside and outside radius of our handrail represented on the oblique plane, and this is going to end up being our face mold. So the next thing we want to do is add this 3-inch stub of straight rail going in here. I like to throw my joint lines a little bit off of the spring point to give you a little bit of room to make the transition in elevation a little bit smoother, so it doesn't all happen in one spot. Takes a little bit of the kink out. So let's throw that stub in there, and once we get the stub in, we're going to the next thing we're going to need to know is the bevels. And what I mean by that is how much is that rail profile twisted at joint C and at joint E. They each have a slight twist to them because of the way that this is configured. So let's walk through that here. In order to get the bevels, let me turn this off here. If you want to get the bevel at joint C, you're going to take and draw an arc from point D where the two tangents meet up to this upper tangent to intersect with it. So you're going to draw an arc to hit this perpendicular at that point there. And wherever this arc intersects the baseline, you're going to throw another line in down to the joint. And then this is going to be your bevel here, right in here. And did I say we were doing C? We're actually doing the bevel at E right now. So we're going to measure this angle from this lower tangent to this new line we just added in here based on that arc intersecting the baseline. So now we've measured that at 5.3. So that would be the bevel at this joint E. Now if we want the lower joint at C, it's a little bit different. We're going to come horizontally across till we intersect this this tangent line here, perpendicular up off of there. We're going to draw an arc from this point here till it intersects with our lower tangent right here at this point. Okay, and then we're going to take the radius from this circle and we're going to move it down and place it right on this intersection. And where that radius meets the baseline, right there, we're going to draw another line down through this joint. So now this angle from here to here is going to be the bevel at joint C, and that is measured at 36.6. So what we want to do now is determine the block thickness that we're going to need to be able to cut this thing out on. So let's go up here and we're going to see both of these bevels here laid out so that we can determine the block thickness. And it's always the bevel that rotates the most that is going to determine how thick of a block that you need. In this drawing we have a block at 3.4 to be able to get that squared out piece of rail in that block. And we have the upper bevel here laid out at 5.3. So the next step that we're going to go into is taking the face mold and laying it out on a in 3D so that you can see what's happening. We got the face mold here, and I just copied it over here. And the next consideration is going to be what is the next consideration? The width that we're going to need on this thing. So up here you can see, in order to get this thing width-wise into a block, we need to extend this point out a little bit for our block width. So that's what I did with here. I've got the block width, and we're going to offset these lines on our face mold so that we can be sure that we can get this thing to fit on here and rotate and still have enough wood. So now we need to get a block of wood that would work for this layout here. And we know that our block thickness is 3.4 and change, so we can we'll extrude that. And I know that if you're doing this on a flat sheet of paper, you won't be able to do any of this. Well, I'm going to do it in this drawing so that you can see what you're going to be doing with this face mold, laying it out on a piece of wood and squaring it out. So you don't need to have a 3D drawing program to take this to the next step, but I'm going to visualize it for you in 3D so that you can kind of see what you're going to be doing with this face mold. So the next thing we want to do is cut the joints. And one of the great things about the tangent system is when you get the block laid out like this and you're cutting the joints are always plumb cuts on these blocks, which is kind of amazing when you think this is going to be twisting and dropping, and I'm still cutting a 90-degree plumb cut on these things for my joints. And that's one of the beauties of this system. So let's cut these joints, which is shown here on both ends. There's square cuts on the end. And we're going to next apply the bevels, these bevels on our joints. So let's take and get them on there. We got the bevel here on this end, on point C. I probably should have brought those the letters up there so we know which one we're on. But let's keep on rolling here. Let's put the rail profile in there. We got it on both ends here, and we have our square line, which is going to be where our original tangents are set up from this drawing right here. Here's from our face mold, the original tangents, which incidentally would be placed in the center of this block and in the center of our bevels here on this end. Let's just do that so you can see it. Just put this guy right on the end here. Yes, sir, here, move him over here. There you go. So the tangent drawings, the face mold drawings that you produce are always dead center on your handrail. So that's where it would actually be in this drawing. And therefore, this square line from the surface would be where these tangents are if they were up on the top or down on the bottom. But that's not actually where they're going to be placed on the top and bottom of this block, because the face mold has to be shifted in a plumb direction when this block is in elevation. I don't have a way to show that. I didn't work that out, so you'll have to believe me. You'll see it in a bit anyway. So you can't just bring this face mold up to the top and down to the bottom. You just end up with a rectangular piece with no twist in it, and it wouldn't work. So what we're going to need to do is shift these tangents to a new position according to our bevels here. So let's do that. Here's our shifted tangent on the top and bottom. You can see the bevel here. We got that 5.6 or whatever it was on that end, and the same on this end with the 36 degree bevel on there. So let's apply now our face mold. Let's get a thin sheet of plywood and cut out a little piece of face mold here, and lay out the tangents and drill some holes in it so that you can see through it, and make sure that you're going to be lining this up right on our shifted tangents. So let's apply those on here. You can see our little windows are set up properly, and you're not going to get the joints to line up. That's not going to happen. You're going to be shifting these things to get our lines, our cut lines on the top and the bottom. So after you get these on there, you're going to want to take and draw a line on there on the perimeter of our face mold, and then you can take them off of there. And these are going to be our cut lines. We're going to be cutting this at these angles. It's not going to be fun cutting that out, but that's what you have to do. So I'm going to present an easier way to cut this out as we go along, but for right now, you're going to have to imagine how you would bandsaw this out on those two different cut lines. So here's what the piece will look like after you cut those sides out, which is great. So we're going to go on to our falling molds from that point. So we need to be able to draw on our sides here some falling lines on here. Now, because of the way that I'm put together, I didn't like winging that. So I would actually do a falling line drawing, which I think I have here somewhere. Well, I'll show you that in a bit. But for right now, we're gonna wing this thing on here. We're going to take the center line of our mold here, our squared out mold. We're going to take our center line, which is this one right here, and we're going to put a piece of flexible on here. Once we get our centers, I usually just put a little a short line on each end from our center here and here, I think I probably have one in here. Nope, I did though. And we're going to get something flexible and try and draw this out on the side here to get our falling line of the face mold. And then we're going to square that out. We're going to cut from this line across to this line. Now this line here, I'm showing some circles on here. I did both sides like this, and I would have done it this way normally, because once you get the center line here set up, it's difficult to get the right offset from top to bottom. You can just wing it and throw it on there, but you may end up with your squared out finished piece having a slightly different dimension in the middle here. So once I got my center line on here, I would draw some circles at 2 1/4 inches in diameter from my center line, and then I would be able to connect and hit those circles on the top and the bottom to ensure that I had them spaced properly, which worked pretty well, I think. So once you get this next phase cut out, you're going to end up with a piece that looks like this. And once you get it to this point, then you have the fun job of putting the profile on that squared out block of wood. So let's take and finish it out here. It's really easy on the computer, isn't it? So this is what it's going to look like once you round these corners off and put this little radius in here on the lower end of it, and you end up with something like this. So let's take now and connect that onto our elevation drawing. We're going to copy and paste that over here and plug it in. So that gives you a good idea of what this thing's going to start to take some shape and look like a volute here. So we can we haven't made the lower one or the cap yet, but let's throw it in there and get a good idea what this thing's going to look like. Now let's turn on some, let's get some wood grain on there. Render, there we go. Okay, not bad, huh? So we got our upper section pretty well worked out, and the next thing we're going to do is our lower section and the cap. So I think we're going to end this video here, or we're going to get too long, but I want to proceed with the lower section and the cap in the next video. I might even dice this up smaller, but I hope that you were able to follow that, and I'm going to sign off now and say goodbye, and stay tuned for the rest of the video. In the next one we'll work on the lower wreath and the cap. So see you next time.